An unusual pulse detected in the sky may be a completely new class of stellar object. The discovery of a neutron star emitting unusual radio signals is rewriting our understanding of these unique star systems. My colleagues and I, this is from the conversational Mishab Caleb, my colleagues and I, the Mir Trap team, made the discovery when observing the Vela X1 region of the Milky Way about 1,300 light years away from our Earth, using the Meerkat radio telescope in South Africa. We spotted a strange-looking flash or a pulse that lasted about 300 milliseconds. The flash had some characteristics of a radio-emitting neutron star, but this was not like anything we'd seen before. Intrigued, we scoured through older data from the region in hopes of finding similar pulses. Interestingly, we did identify more such pulses which had previously been missed by our real-time pulse detection system, since we typically only search for pulses lasting some 20 to 30 milliseconds. A quick analysis of the times of arrival and the pulses showed them to be repeated about every 76 seconds, whereas most neutron star pulses cycle within a few seconds or even milliseconds. Observations showed PSR J0941 4046 had some of the characteristics of a pulsar or even a megatar. Pulsars are the extremely dense remnants of collapsed giant stars which usually emit radio waves from their poles. As they rotate, the radio pulses can be measured from Earth, a bit like how you'd see a lighthouse periodically flash in the distance. However, the longest known rotation period for a pulsar before this was 23.5 seconds, which means we might have found a completely new class of radio-emitting object. Our findings are published today in Nature Astronomy. An anomaly among neutron stars? Using all the data available to us from the Meertrap and Thundercat projects at Meerkat, we managed to pinpoint the object's position with excellent accuracy. After this, we carried out more sensitive follow-up observations to study the source of the pulses. The newly discovered object, named PSR J0941 4046, is a peculiar radio-emitting galactic neutron star which rotates extremely slowly compared to other pulsars. Pulsar pulse rates are incredibly consistent, and our follow-up observations allowed us to predict the arrival time of each pulse to a 100 millionth of a second. Apart from the unexpected pulse rate, PSR J0941 4046 is also unique as it resides in the neutron star graveyard. This is a region of space where we don't expect to detect any radio emissions at all, since it's theorized the neutron stars here are at the end of their life cycle and therefore not active or less active. PSR J0941 4046 challenges our understanding of how neutron stars are born and evolve. It's also fascinating as it appears to produce at least 7 distinctly different pulse shapes, whereas most neutron stars don't exhibit such variety. This diversity in pulse shape and also pulse intensity is likely related to the unknown physical emission mechanism of the object. One particular type of pulse shows a strongly quasi-periodic structure, which suggests some kind of oscillation is driving the radio emission, and these pulses may provide us with valuable information about the inner workings of PSR J1941 4046. These quasi-periodic pulses bear some resemblance to enigmatic fast radio bursts, or FRBs, which are short radio bursts of unknown origin. However, it's not yet clear whether PSR J0941 4046 emits the kind of energies observed in fast radio bursts. If we find it does, then it could be that this is an ultra-long period magnetar. Magnetars are neutron stars with very powerful magnetic fields, of which only a handful are known to emit in the radio part of the spectrum. While we've yet to actually identify the ultra-long period magnetar, they are theorized to be possible source of fast radio bursts. Brief encounters. It's unclear how long PSR J0941-4046 has been active and emitting in the radio spectrum, since radio surveys typically don't usually search for periods this long. We don't know how many of these sources might exist in the galaxy. Also, we can only detect radio emissions from PSR J0941-4046 for 0.5% of its rotation period, so it's only visible to us for a fraction of a second. It's pretty lucky we were able to spot it in the first place. Detecting similar sources is challenging, which implies there may be a larger undetected population waiting to be discovered. Our finding also adds to the possibility of a new class of radio transient, the ultra-long period neutron star. Future searches for similar objects will be vital to our understanding of neutron star population. This is from University of Sydney, Manisha Caleb lecturer from The Conversation. It's here on Creative Commons license on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.